Today we're going to look at two more triangle congruence theorems. The abbreviations are AAS and ASA. We're going to talk about what they mean, what they stand for, and how we're going to apply them. So let's take a look at the first one. AAS stands for angle, angle, side. Two triangles are congruent, which means the same shape, same size, if an angle, angle, side are equal in that order. So notice it has to be in that order. We can't skip over an angle. We get the second angle. The following side has to be the same, so in that order. Let's take a look at exactly what this would look like. So we have two triangles. Let's take a look at the left one, and let's start at this angle down here, the single arch. If we start at this angle, the next angle, and then the side, that would be AAS, right? So let's take a look at this other triangle. The same order applies. We start at the first angle, go to this next angle, and then the next side. So the order is AAS, and if that's true, the two triangles are equal. Now, as I said before, you could flip this and call it SAA, side, angle, angle. It'd be exactly the same. But the reality is, it's congruent because if two triangles share this in common, there's no way to draw the second triangle to make it different than the first one. It's kind of like glue. It has to hold together the same way as the first one. Therefore, angle, angle, side is another congruence theorem on top of the other two we've learned so far, SSS and SAS. Let's take a look at the other one. This one is angle, side, angle, and again, if they are in that order, angle, side, angle, those two triangles are congruent. Let's see what that looks like. So down here we have angle, side, angle. If we start at the double arch, angle, side, angle. Over here we have angle, side, angle. Again, you can't draw the other triangle differently without making it the same as this one if their corresponding angle, side, angle in that order are the same. Therefore, they're congruent, they're the same triangle. We could flip it, make it go the other way, and it'd still be the same triangle. And if you flip ASA, it's still ASA. So ASA is ASA. You can think of it a lot like SAS, right? It's just two angles and a side in that order. Okay, let's take a look at this example. Are these two triangles congruent? All right, so right off the bat, they give us that these two sides are the same, and they give us these two angles are right. So is that enough to prove congruence? Well, no, but let's take a look at our steps we've learned, same steps we learned in the previous lesson. Can we know any equal sides based on this diagram? This one's no, because they don't really share a same side and we can't conclude anything about the other two. But let's take a look at the second step. Let's know any equal angles. Okay, so you should be able to see these two angles are vertical. So we're going to put an arch there and an arch there. So now what do we have? Well, let's just start with the orange angle up here for this triangle. This goes angle, angle, side. So a lot of times I just tell my students, label each, whoops, I wrote down something different than what I said. Label each triangle what the order in which it goes and see if they're the same. Okay, let's start at this triangle down here then. Angle, angle, side, right? It doesn't skip over any angles. So since these are both angle, angle, side in that order, we can conclude that yes, they are congruent because of angle, angle, side. This is a new congruence on top of the other two we've learned. I just wanted to split it up into two separate lessons because sometimes it's a lot to manage at once. All right, let's take a look at this one. Let's go ahead and look at step one. Can we know any additional sides that are equal other than these sides they give us? And the answer is no. Again, they don't share a common side, so we really can't conclude that. Okay, they do give us two angles. Can we figure out another angle? Okay, and if you noticed again, we have those two vertical angles. So yes, we can actually conclude that those are the same. So I'm going to put two arches right here. So we have, now we have three things. Is this enough? Well, again, let's label the top one. It goes angle, side, angle. If we start at the same angle down here, it goes angle, side, angle. So is that the same order? And the answer is yes. They're both angle, side, angle in that order. And so the answer is yes, they are congruent because of angle, side, angle. So that's the second congruence theorem that we've learned today. Let's take a look at the third example. Okay, so what do they give us in this diagram? Well, they give us a side and an angle and a side and an angle. Step one, can we know any equal sides? Okay, the answer is yes, they do share this side in the middle, so let's go ahead and mark that with a single notch. Step two, know any equal angles. Well, Other than what they give us, we really can't conclude this one up here for various reasons. We don't know if these two lines are parallel right here, so it's hard to just assume that those are the same. Now let's go to step 3. Are they congruent? Well, let's take a look at this first one. This goes side angle angle, so that's SAA. That should, or I'm sorry, it goes side angle side. Okay, yeah, so side angle side. But this one over here doesn't do that. If we start at the same side up here, it goes side side angle. Okay, and side side angle just doesn't work. And you notice a discrepancy between the order of the top and the order of the bottom. The answer is no. So again, we've learned two more congruence theorems, but that doesn't always mean that, you know, just because we have more options, we're still going to have triangles that aren't the same, just because the order has to be right. In this case, it's SAS and SSA. That's it for this lesson. Again, we learned two new triangle congruence theorems, AAS and ASA, angle, angle, side, and angle, side, angle. If you have any other questions about this lesson, let me know.